All right, we are at section 17.5, resonance. This is a single slide um, PowerPoint, but I've got a little Walter Fent demonstration to show you. And here they're showing you a little vibrating blade. It's a mechanical blade. When the blade vibrates at one of the natural frequencies of the string, large amplitude standing waves are created. So you have to have the little vibrating blade in order to get good vibrations at a resonant frequency. Now, resonant frequencies can be bad. If anyone watched that Tacoma Narrows Bridge that uh, we discussed in, I believe it was in chapter 15, resonant frequency is not always good. It can cause destruction. Uh, certain uh, uh, equipment can start vibrating. If it starts vibrating at a resonant frequency, it can tear itself apart. Uh, the sometimes you can even feel your automobile shudder as you run through a resonance. You don't want to. It doesn't happen too often, but I have felt it on occasion. So there's some cases where you don't want resonance, and uh, let's change the share. Oops. Uh, let's go to Walter Fent, our old friend Walter Fent, and I'm going to change this to the elongation diagram, and let's start this. And you can see that the if you look at the blue diagram, it kind of has a hard time getting the timing going, and then it finally does settle down, but it gets a hard time going. And let's reset that. Let's put this somewhere over on the other side. Let's try 5 and start, and you can see that uh, it has a little bit of trouble there. Also, you can see how the the uh, uh, the blue is not consistent. Now, I've played with this before, so let's go here to 2.44, and that is the resonance. Um, and you can see how if we go at that particular frequency, it the the waveform grows very nicely, uh, and so because that's its resonant frequency. Now I can go through all of these um, in an amplitude diagram, uh, and you can see where the resonance is. Let's reset it by reloading, and now it's the amplitude diagram. And so if we start it, you can see you see this peak here. That's the resonant. That's the resonance. So here we were at 1. We're way off resonance. Let's change this to 5. I think we did 5 earlier, and reset it. And start. You can see that we're on the other side. Now let's change this to 2.44. Reset. That's where we were. 2.44 is right at the resonance, and you can see it it does very nicely uh, at growing the amplitude of the mass on the spring. And if you play with this enough, you can change the spring constant and the attenuation such that the spring will actually the uh, animated spring will actually break. I won't try that, but anyway, there's a little idea of resonance. So resonance can be good, but it can be dangerous under certain conditions. All right, I think that's enough of resonance, um, and we'll stop it there.